Hello everybody, welcome to this episode of Programming and Algorithms. In this episode we're going to look at software development methodologies. And what that means is, how do we manage the process of developing software? So it's not simply a case of one person sitting in a room coding away by themselves, but if we have a group of computer programmers and they're all working to design a common product, how do we ensure that everybody is effectively doing their piece? How do we ensure that the quality of the code produced by each programmer is comparable? How do we make sure the whole thing will work together? So we create processes, a bit like project management processes, to help ensure that the code that gets delivered, software, is of good quality. So I'm presenting a picture here of a kind of timeline of methodologies. It's a rough and ready timeline. But I'm just saying in the 50s, code and fix; in the 60s, design, code, test, maintain; 70s, waterfall; 80s, spiral; 90s, the V model and red; and then in the 2000s, where we have the agile methods. So for this talk, this part, we're just going to do the first 3 decades of coding, the 50s to the 70s. So in the 1950s, the approach to coding in general could be characterized as code and fix. That is also called code like hell. All it means is people just wrote code for whatever it was required to do, and then if it broke down, they'd fix it. So there wasn't a great deal of emphasis placed on planning and design. Coding was the design in a sense, and there also wasn't much thought about testing. They just released the code, and then if it worked, great. If it didn't, well, let's just fix it. So the expectations people had in the 50s of working code was so low that this sort of thing was acceptable. And definitely, it's beneficial in the sense that there's no overhead in terms of management, process management, documentation, things like that. And all it requires is the ability to code. There's no team skills, there's no integration, there's no software testing skills needed. Unfortunately, there is no quality control here, and it's very risky as an approach. So by the 1960s, they created an approach called design, code, test, and maintain. And we would see that as very similar to how houses are built, or architects are used in the house building process, where the architect designs, the builder builds, the people test what the building is like and create a snag list of things that haven't been done, and then once they move in a few years later, they maintain the house. So maybe they fix a leaking tap, or maybe they climb onto the roof and fix a broken tile. Every once in a while, the maintenance requires a significant change. So maybe you'll create a small extension out of the back of the house, and that's big maintenance, whereas normal maintenance are things like gluing down a loose tile or something like that. So the same with software. Design is to specify the requirement for the system with a picture or a diagram, write the code, create the software, test if the system is working, and test as many inputs as you can think that the user might put in as possible, and check if the code captures them all, and then keep the code up to date. So maybe make it interactive with the web, or change the logos if the organization changes its look, things like that. In terms of the advantages and disadvantages, they're almost the flip of the previous one. The advantage are there's more process control, and therefore it's less risky, whereas the disadvantages are there's more overhead in terms of management, and it requires a lot more expertise. So if we move on to the 1970s, we'll look at what's called the Waterfall Model. So the Waterfall Model is based around a paper developed by W. Royce in 1970 called Managing the Development of Large Software Systems. And it was an IEEE publication. Just to say, Winston Royce was a computer scientist who worked for Lockheed, and he was the first person to describe this waterfall model. Just to be clear, he was saying this waterfall model mightn't necessarily be a good idea, and he opens with, I'm going to describe my personal views about managing large software developments. I have had various assignments during the past 9 years, mostly concerned with the development of software packages for spacecraft mission planning, commanding, and post-flight analysis. In these assignments, I've experienced different degrees of success with respect to arriving at an operational state on time and within costs. I have become prejudiced by my experiences, and I'm going to relate some of these prejudices to you in this presentation. So what he says is, for a small presentation, it's perfectly okay just to figure out what's needed, do an analysis, and then code. But for larger developments, a more systematic approach is being used, and it works by suggesting what the system requirements are, what we need it to do, and then what the software requirements are, what the software should be, an analysis of the needs of the project, a design of the project, coding of the project, testing, and then making it operational and maintaining it. So the system requirements are to identify, select, and document what are the requirements of the project, including financial scheduling and what functions you want the system to undertake. The software requirements are to identify the software features necessary to satisfy the system requirements. The analysis is to methodologically work through the details of each software and system requirement. Then the program design is to use programming and design methodologies to describe in detail everything that we've created up till now, and typically diagrammatically using pictures as part of that design and pseudocode. Coding is to implement the design stuff from the previous stage. Testing is to test all the possible inputs that the user could create, or all the possible ways that the code could be run to see if it's robust. And operations is to install and configure the completed system. Now, it's really important to note that Royce said, "I believe in this concept, but the implementation described above is risky and invites failure." So Royce believed it's good to have a staged approach, but the waterfall model, so-called, is not one that he necessarily thinks is the safest way to go. So what he says is, you should always be able to revisit a previous stage. It's not good enough once you get to analysis to say, all right, well, once we've signed off analysis, we never need to go back and do further analysis. If at a later stage in the process we identify further needs or further requirements, we may need to revisit analysis, reincorporate elements and new elements into the design, recode, retest, and rerun. So, not simply going forward, we have to be able to go back as well. Royce also makes an important point that testing happens very late in this process. So testing happens way at the end, whereas we should actually test as soon as we can. And as soon as we've decided what software we want, we should start knocking up prototypes and get testing then. And he gave some rules, some suggestions. Program design comes first, document the design, do it twice, plan testing, and involve the customer where possible. So, program design come first simply means let's do a design phase in between the software requirements and the analysis phase. So we have a preliminary program design, a prototyping approach, we would almost say, and that's exactly what Royce is getting at here. And I would see this as very much almost like an agile approach, which we'll see later on. But in 1970, Royce was saying, this is a good idea. Knock up a quick program design here. Let's decide what technologies we're going to use and what our requirements are. Document the design a lot. Document. It's really important. And at every point, there should be different kinds of documentation. Do a pilot, do a rapid prototype, is what Royce is saying. Again, this is 1970, and Royce is saying, do a rapid prototype as quick as you can. So in the preliminary program design stage, jump immediately into an iteration, get something quick up and running, and then how will that feed into your analysis, program design, coding, testing, and operations. Plan, control, monitor the testing, absolutely. Testing is really, really important. So to test a range of ways, inspect the code, test it, make sure you adhere to procedures and use proper testing tools, all that kind of thing. Make sure the design of the testing has happened way, way early as part of the analysis stage. And involve the customer. And again, this seemed like a revolutionary idea when people were saying it in the late 90s, early 2000s. But Royce was saying this in the 70s. Whoever is asking for the software, the more we can get them involved in the process at the design stage, at the development stage, at the testing stage, the more likely we are to get a product that will be fully satisfactory for their requirements. So get the customer in there specifying, get them in to look at preliminary design, get them in to review the software, get them in at testing, get them to sign off. So we have quite a complex process, really, a much more sophisticated and nuanced model on the left than what you can see on the right. So on the left we have what Royce was proposing as this would be a good approach to software development, and on the right is what he's saying is not satisfactory. So the thing on the right is what we typically call the software waterfall lifecycle model. A lot of programming people ridicule it as being silly, and even the person who first created it was doing exactly the same thing. He was saying this is a silly approach to use a waterfall model. We need a much more iterative, much more lightweight, much more customer focused, and much more documented approach. So that's the software waterfall lifecycle model. And that's the end of software development methodologies from the 1950s to the 1970s. So thanks very much. We'll see you on the next episode.